Hi, everybody, and welcome. I'm Ari Waller with Neo4j. I am the DevRel Community Manager, and I'm excited to be here with the brilliant Alison Collette, who is our data science subject matter expert on our developer relations team. She's going to show us the power and the value of graph analytics in today's session. Hey, Alison.
Hey, Ari, thanks so much for having me. And I want to thank everybody who's joining us now and in the future. So, I'm really excited to walk through today how graph analytics can help you uncover patterns and connections that you don't even see in a graph to begin with. So, there's some advanced techniques that we're going to talk about in graph analytics. And ultimately, it's going to lead up to how it can help push you forward professionally as well.
Exactly. And since this is June, which is in our community forum, Neo4j Certification Month, we'll wrap up walking you through some of the key Graph Academy courses you should take in case you're looking to possibly pass the Graph Data Science certification this month. While this isn't a test prep session per se, we're definitely going to give you a good overview to see if this skill set is something you'll want to add to complement your existing skill set. So with that being said, let's dive right in and turn it over to Alison.
Thanks so much, Ari. As I mentioned, obviously, we're going to be talking about Aura Graph Analytics, and Graph Analytics is actually graph data science. So it's all of the graph algorithms, and what we're going to walk through today is what you probably are already working within your graph and all the different ways that graph analytics can move what you're working on forward. So, first of all, we're going to talk about business decision making and how it depends on, whoops, sorry, let me just move forward. Introducing Neo4j or Graph Analytics, going beyond traditional analytics. So, what we're looking to do is we're looking to uncover deeper insights from your data sources. What this allows you to do is you're going to be able to use 65 different graph algorithms to eliminate the complexity of some custom queries. So if you're already working with graph, you probably have had some pretty challenging queries that you've had to run in Cypher, lots of different case statements and maybe some different pieces. We'll look at some of those. But the best part about it is that now Aura Graph Analytics is actually serverless. So within your Neo4j Aura instance, you can actually see on the side graph analytics and you can spin up what you need. So you can spin up and spin down sessions as you need when you're using graph analytics. So one of the reasons why I'm really encouraging folks to investigate the certification is two reasons. One, I just came back from AI Engineer World's Fair in San Francisco, and the number of people there who, because graph is such an important part of AI, the number of people looking for graph specialists is definitely picking up. So adding the certification can really benefit you as you're moving through the AI space. So just a little bit about that. So, what we're going to be talking about today, obviously, is the hidden data connections that drive results. So, we have these specialized algorithms, and they do a number of things. They can boost your model accuracy. They can really connect any data source so you can really improve your ETL. And then you're really able to scale those analytics precisely when needed because it is serverless and it is on demand. So, how does it work? Obviously, like we said, direct connect, zero setup, ready-made algorithms, and it scales seamlessly. But what is it that we're actually scaling and what are we getting into? So as I mentioned, in your Aura DB, Graph Analytics is available in the console. And what you can get to is you can achieve in minutes what would normally take weeks to build from scratch. So let's dive into this a little bit. So what I want you to be aware of is we call this the 7 graphs of the business. And across the business, you can be working in any one of these sorts of areas. So we've got employees, suppliers, networking, and security. So I imagine the folks who are here, some of these areas sort of look familiar. If anybody wants to pop in and say which of these types of areas you're working on. Tim, I know we have our first question, which is how much is the certification? The certification is free, which is the best part. We'll go over that at the end as well. But yes, the certification is free. So when we talk about the business, let's first talk about understanding patterns in your process data. So when we think about process data, it could be anything, and process automation is huge right now, obviously, since AI is everywhere and Gen AI is there. So what it can allow you to do is it can allow you to identify bottleneck identification. So if we're taking a process and we're automating it, when you track that process as a graph, right? Because it's naturally a graph, one thing happens and then the next and the next, you can start to identify those bottlenecks and you can actually monitor that process. So what does that look like? In the graph, you can identify highly connected nodes with Cypher. So if I am working on, say, a graph rag application or a rag application, I can see which node is used the most, or I can see something that's happening the most frequently. But with graph analytics, what we're able to do is we can find bottlenecks in the process with what we call bridge centrality or betweenness centrality. And the nature of that algorithm is around looking at what is sort of like the connection point. So if you think of a graph of all the people in the company, you've got all of the people in your department here and all the people in another department here, and they're all very highly connected to each other. But there's one person, maybe Ari, who's the connection point between, say, developer relations and engineering. And so that person has a high bottleneck potential because there's no redundancy of communication across those pieces. And so that's what we call bridge centrality or betweenness centrality. And so this is one of the ways that you could use a graph algorithm like betweenness centrality to really understand what's happening in that process data, or find like those high risk points, those high like impact failure points within the system. So next, what we're going to talk about is we talk about really these are the nodes. So you can see it here. We've got the yellow nodes on the right and then the yellow nodes on the left. And this green node in the middle is really important because it's the only one that connects those two sides. So this is the crucial connector, this possible bottleneck, and it's really that important bridge between these two aspects. And this could be anything from even supply chain. It could be some sort of network. There's any number of scenarios where that might be important. And so this is one of those important algorithms that you can use. The next thing that we're going to talk about is an example where we had a company, they got an 83% reduction in query time because they're able to quickly pinpoint the root cause of the problem within their activity. So they're looking at activities, resources, and events, and they were able to really see. So it really made a big difference in that root cause analysis problem. So that's one thing to consider when you're looking at your process automation. Next, we start to think about our customer data. So customer information, payments, history. There's a lot of work that we do with customer data, all of us. So whether it's recommendations for customers of products, loyalty programs, churn prevention, customer offers, dynamic pricing, intelligent ads. The customer 360 alone is actually a really powerful use of graph. So what does that look like? So in this case, in the graph right now, maybe you're trying to find similar customers based on attributes. So maybe Ari and I live in the same town, or we have a similar product that we purchased. And so this allows you to identify some similar nodes based on the attributes. So like demographics, maybe we're in the same age profile. Maybe, as I said, we're in the same zip code. But in this case, when we try to expand into graph analytics, we can actually discover customer context using node similarity. So we actually have, everyone right now is talking about your vector embeddings of your language. We actually have node embeddings of the nodes themselves. So what this allows you to do is capture the larger context within the graph by comparing sets of nodes based on shared neighbors. And those shared neighbors give you node similarity. So the way a node embedding works is it maps sort of the structure of one node, say you, the customer, and all the different nodes that you're connected to. And then it will look for similarity. So what does that look like? So in this case, we're looking at, so we see there's me and there's Ari, and we have this node in common. And so it allows us to find context based on this node similarity. And what does that look like in practice? Well, in practice, we have a customer, US Health, and they were able to increase their data science adoption 150%. So it allowed them to get deeper insights into their customers. And that allowed them to use a lot more data science, a lot more machine learning, a lot more AI to really dive deep. And the important thing here is that they've got over 1 billion nodes, over like 2 billion relationships. So sometimes folks will ask us, how do these algorithms run at scale? And one of the things about using the Neo4j graph algorithms rather than say, an old school network X is, this is all that we do. Our data science engineering team has worked really hard to optimize all these algorithms so they work really, really well at scale. So if either you're working in graph or you're a data scientist or someone in machine learning, AI, who's looking at these types of problems, just recognize that there's a whole host of algorithms that can help you do this in a more robust way and at scale. So next we start to look at network and security. And these are always some of the most interesting ones for me. So identity access 360, identity resolution, reputation scoring, threat detection. And there's two things about this that are really, really interesting to me. One is the identity resolution. And what's interesting about identity resolution is that it's not even just in network and security. I know that a lot of times we have a variety of ways that we're trying to find out if people are similar. Like, do I have this person in here two ways? Like, do I have A Cosette and Alison Cosette and Alison K Cosette? And how do I know that they're the same person? And again, old school fuzzy matching. But one of the things that becomes possible is you can look for common connections. So I was lucky enough last year during the election to be able to see what and help Syracuse University when they were working on the election graph. And one of their interesting things that they worked on was looking at advertisers in Facebook and Instagram. And what they were able to find is they would have two seemingly independent entities posting an advertisement, but they happened to share an email address. And then there was another entity that didn't share the same email with the first entity, but shared a phone number with that middle entity. And what we were able to find is they were able to find a group of seemingly independent actors that were actually all working together. They were one entity. So that's a really interesting one for me, the identity resolution. And then honestly, threat detection, reputation scoring, there's lots of ways that you can look in network and security to have some additional pieces there. Access patterns as an example. So it could be that usually you're looking at model dependencies with Cypher. So potentially approximate dependency chains in directed relationships. But what we can do with graph analytics is that we can actually use the topological sort to determine critical dependency chains. So if we think of, similar to what we looked at in process, and when we look at the actual networks and security, we can see, there's this really important dependency that's in here. So we know that if there's a problem with this node, so like we go 1, 4, 5 goes to 6, 1, 5 goes to 6. If you hit 2, then you go to 3 and they go to 6. So what we're finding is that there's that important moment that a lot of different pathways are passing through this one moment. And it may not even be like between this centrality. It could be one of our other centrality algorithms that brings that up. So Dijkstra. There's a number of different ones that you can use. So these are really interesting to find these really critical points, these mission critical assets that are in this network and security area. So an example of that in practice is we have Intuit, who used Neo4j. They have 100 million customers protected. They have 4 minutes to determine a blast radius. So if something happens, they know within 4 minutes exactly how far it's going to go and exactly what that blast radius is. So again, there's so much that can be done in a variety of places within the business. Next, we talk about employee data. So whether it's talent, learning and development, career management, organizations, who's who. So an easy thing to think about is identifying common connections with Cypher. So maybe recommending new mentors according to common neighbors. So maybe there's a common manager or maybe there's a common skill set. But one of the things that we can do is we can actually make it much more sophisticated. So rather than it being something more simplistic, we can say recommend a new mentor through quality common neighbors via advanced algorithms like resource allocation. So you can think, maybe Ari's a good mentor for me because he's been in my role before. We have some overlapping skills. And when I look at the promotion cycle, his current role is one of the potential upstream roles for me. So there's lots of different ways that we can look to enhance organizational efficiency as well. So DXC actually used it, and they were able to use this to enhance their career navigation. And two things happened. One, first of all, there's a 13% increase in internal hiring, which means they were able to promote from within. We know for a fact that when you promote from within, the onboarding time into that role is significantly reduced. You have that institutional knowledge, you have that product knowledge. And so that manager or that executive can be much more impactful much sooner when they're internal. The other piece that happened for them was there a 40% attrition reduction by using Career Navigator. By enabling your employees to see what's possible for them, connect them to mentors that can help them get to that next place, you're really keeping people around longer, you're increasing their personal career growth, and it is everything that you can do to really make that company reduce that employee churn and really promote more from within. Another example that we often look at is transactions. So it can be anything from money laundering, payment scams, credit risk, claims fraud, whatever kind of transactions you have within your organization, these kinds of things are going to come up. So whether it's, e-commerce where that money is yours, or if you're in like say banking or credit cards and you're looking at the flow of other people's funds, these types of things come in they're really handy, and they really are going to help you address fraud. So in Graph, you could identify possible fraudsters by attributes. So, is there a certain IP range that might be happening? Is there something, like interesting that they're out of their regular geographic area? But when we start looking into graph analytics, we can actually identify fraud rings with something called Louvain. And Louvain is what we call a community algorithm or a clustering algorithm. And what it allows you to do is find this potential collusion by detecting unusual densely connected communities. And I gave you an example of a connection of the attributes were say email or phone number, but this is going to go into other things like addresses or IPs, like IP addresses, like we mentioned. It could be that they're ordering, similar, like different folks are all sending to the same address. Like there's a lot of different people that are sending to the same address. So there's lots of different ways that you can use the activity and not just the attributes to really expand and find these clusters and these rings. Again, we have an example here where they were able to check fraud and get fraud detection in less than 2 seconds. They were able to reduce fraud overall by 20%. There's another question that says, do analytics include all producers and consumer? Kafka and Linkerd, for example. So The analytics that you're going to be running are going to be running, and I'm not sure if this is going to answer your question, Tim, so definitely let me know. They're going to be running on whatever your graph, so whatever you have inside the graph itself. So we certainly have lots of different connectors. So if you go into Neo4j and you look up the connectors, we've got all different kinds. You can connect to all different kinds of data sources, and we have automation for those as well. So there, and I hope that answers your question. If it doesn't, definitely let me know. But that's really the biggest thing is, you're sitting on so much data that once you put it into graph format, can allow you to see these things. So for example, we have some customers who are actually maybe in Snowflake, and they want to create a projection of a graph and then write that data back. So that's a smaller way that people use it. But really, one of the reasons I like showing the entirety of the 7 graphs of the business is things also get really interesting to me when we start crossing, say, from transaction area into process, or from process to customers, or process to transactions. So one of the things, so we can look at things like, oh, if we have a change in our customer service policy, and we can track that, and we can track the conversations about it, and we can then have a direct link to the impact of which transactions were mentioned in this particular conversation with customer service, or which products came up the most often in customer service. We can start to traverse the graph. Or maybe we saw that there was a supply chain issue that impacted product availability, that affected the transaction, which then connected to customer service process. So really at that level, I'm showing you, the smaller use cases, but you can really elevate the conversation and look at it at a much more systemic level across the business as well. So let's talk about product. I mentioned product, right? We can look at inventory, but like I said, we can also look at pricing. We can look at reviews. We can look at all different aspects of the product in practice. So we may start out with natively leveraging the graph as the database, so performing simple queries on top of the graph database in Aura. But where things get really exciting is you can use pre-built embedding algorithms to transform your graph into this vector space. So like I said, that node embedding is one thing that you can use. So now, or we've been doing a lot of work over the last 2 years with product descriptions and how those can feed into your chatbots and into your AI systems. So whether it's the embedding of the product description, the embedding of the customer purchase history, there's lots of ways that we can use the actual embedding of the graph. So maybe you have your product set up, or I've got a product and we've got relationships to different attributes or different implementations. So we know that this version of, this software is compatible with this, this other software, right? So we can see something like that. Or we know that this windshield wiper is good for these different car models, right? So being able to connect those and say, oh, well, if the windshield wipers are connected to those and the windshield arm is connected to those, then maybe this new windshield wiper that is connected to this car might also be compatible with this arm. I don't know. It could be anything. It depends on what your product scenario looks like, but it's a way of looking for that compatibility and looking at it across. Some interesting use cases that we've seen that are very similar are actually in, say, drug discovery. So rather than the product being, like a windshield wiper, the product may actually be like a drug mechanism, and that drug acts on different proteins and treats different systems. So maybe the next drug that you're working on, you find that it has similar proteins and similar symptoms, and you can say, oh, well, maybe it actually could be tried for this diagnosis or for this element. So It's much more complicated than that. But this idea of the graph embedding and understanding the structure of what is the element and what is it connected to, and how can we reuse it in other purposes, that's one of the things that becomes available to you when you're leveraging graph embeddings. The next thing that we're going to do is we're going to talk about, let's see the example. This is Basecamp Research. They are very much in the life sciences. So they actually help them operate at scale, and they use their science algorithms to help them get their work done more efficiently. Basecamp Research is actually fascinating company. They've gone through and they have a graph. They basically are trying to build an entire graph of the natural world. So it's one of my favorite implementations. Like, I find that what they're working on really interesting. So we've mentioned sort of somewhat a little bit around this idea of supply chain. Supply chain is the classic graph, right? So route planning and optimization, supply chain visibility, inventory planning, risk analysis. We talked a little bit about betweenness centrality as a risk, right? We look at route optimization is actually a really great one too. I worked with someone where they said they were having a problem where they ended up having trucks that weren't at capacity, and they wanted to rework the routes so that they could have fuller trucks more often to be more efficient. So there's a number of different ways that you can go about that. So natively in Cypher, you do have like one version of the shortest path. So you can easily calculate like, oh, what's the shortest path between one location and another. But it's not always just about the location, right? It's about what is the weighted, what is the cost. So for example, we were talking about this a little bit earlier. So it's similar to when when you're using Waze and you can choose, do I want to go the fastest route or do I want to go the route with the fewest miles, right? So it may be a little bit longer, but because you can drive faster on the highway, it's a quicker route. Or maybe you want the one with the fewest tolls. Those are what we call the cost. So the Dijkstra algorithm is actually the ability to find the shortest path with the different cost weighting. So that's another really interesting algorithm that gets leveraged here. So when we go through and look, and again, these are just some examples, right? These are just the seven uses, and I mentioned one or two within each of them, but I'm sure you have graphs that you're already working on that are some version of these or are an interesting unique case that are a little bit different. But ultimately what we're looking to do is we're looking to reveal these hidden connections in the data and leverage the algorithms. So if you think about your traditional machine learning algorithms, you've got your structured and your unstructured, right? So we still have those, right? Like the unstructured is something like those clustering algorithms we talked about. Node embeddings are unstructured because there isn't a definitive answer. We have on the more structured side, there's link prediction. So what is the likelihood that what will be the next, say, diagnosis in a healthcare chain, or what might be the next product that someone buys, or is it likely, like we said in drug discovery, that this drug might be helpful, that link prediction. So we've got that. Again, you're leveraging different sources, but not only do you have your traditional, say, a regression where you've got a classification problem or a regression problem that you can run in graphs. You have a whole host of algorithms that are graph specific. And that's what we really wanted to highlight today. The shortest path algorithms, the node embedding algorithms, the things that really can only be solved by a graph. Now, I said at the beginning, I was going to talk to you a little bit about, what this means as far as career goes right now. As I mentioned, I just came back from the AI Engineer World's Fair, and there's so much that's being done. I gave a workshop on leveraging these algorithms to really understand advanced analytics I was showing it in a GraphRag scenario. So one of the things that we do is I recommend that the first thing you do is you run a KNN based on the embedding. So you're creating that connection, right? So first you connect, and that uses your first algorithm, which is KNN. The next thing I suggest is that you do what we call clustering. And the reason clustering becomes helpful is you can actually cluster the documents in your RAG application. And what that allows you to do is it allows you to manage them at scale. So I want to look at a whole group of documents. If they're really similar, do I have redundancies? right? And then what you can do is then you can watch pathways of, say, in a chatbot conversations as the conversation and the process travels across the different communities and the different subjects of your documents. So in this case, we're looking at a number of different algorithms, and all of those different algorithms are really just there to help you scale and maintain, say, your data, your RAG data set, your graph RAG data set at scale, and then understand how is someone using the AI that I've built? How are people traversing? I'm working on some interesting things right now where you can actually track like tools that the agent uses, right? So if any is anybody here building agentic AI or has looked into agents? Yeah, we got two folks saying yes. Yeah. So if you're doing anything in the agentic AI space, being able to track them with these graph algorithms is going to be really important to understanding the behavior of your AI. So what's interesting to me when we look at the AI moment is graphs are more and more important every day. We talk a lot about, MCP servers. We talk about evaluation, right? So, and then we have to start looking at the evaluation of the agents and the servers. So it's really, one of the things that's interesting to me from a career perspective is graphs really are underneath AI all the time. The other thing that I've always found super interesting is that the whenever you see images of AI, they always show the brain and like all the nodes and the connections. AI is always shown as a graph, so that's also really interesting to me. So I know Ari's going to talk us through a little bit more about how do you dive into this, how do you move forward, what can we do, and so Ari, are you still here? I think you're here.
I am still
There
here.
he is. Ari is still here.
Wouldn't miss it for the world, Allison. No, that was really, really awesome. Thank you so much for sharing that. And I think that really some great information has been shared today. And I want to I'm looking down just to make sure there's no last minute questions that are coming in. But feel free if anyone has any questions to ask Allison before we wrap up. But while we're doing that, I'm going to go ahead and just share a couple of things. First of all, we want to share. Let me actually. It was a little bit in reverse of what I wanted to share, but I'll do it this way anyway. June is Neo4j Certification Month in the community, and what we found is that we have quite a few people that have taken advantage of our amazing education courses. And I'm not just saying that because I'm part of the company. We really, it would be great, if I could, but no, we really do spend a lot of time and resources in ensuring that graph database technology is accessible to everyone. Thus, to answer Tim's question earlier, the courses are free, and they are very, very also hands-on. And there's really some great learning capabilities in there. So you'll actually not only get a certification that you can get a badge and put on LinkedIn, you will also get an amazing t-shirt that you get to wear as well. But for the month of June, if you get a new certification for Neo4j, whether it's our core professional certification or graph data science, which Allison gave us a high overview today, if that's a skill set you want to pursue, we have a beanie. Now you have to go through this QR code in order to get that. So there's a little process just to make sure, because it's an added bonus only for new certifications in the month of June. So if you have one certification, go ahead and try for the other. But what I really wanted to show you first here was the road to get this. So here is another QR code that you can hit, and this will take you to the graph data science certification page where you can actually take the test if you'd like, but also the recommended prerequisite courses. Now, the prerequisites for this particular certification, there's fewer courses than the first one, but still really, really important ones. If you haven't taken the fundamentals of Neo4j before, you've had an overview today, but this is truly an introduction to graph data science, and also getting into those fundamentals, and then of course making sure that you truly understand some of the core items that you will need in order to obtain this certification. So With that being said, and we are about to wrap, I just want to thank you, Allison. That was really awesome. And I really, really think the others here, from some of the questions we received and some of the items that I'm seeing on other screens, that this has been really, really helpful. So thank you.
You are most welcome. The other thing I wanted to say about the prerequisites is, I mean, again, we work here, but our Graph Academy team, Martin and Adam, who lead up Graph Academy, I have
Yes.
to say, I love their approach to the way they build courses, because the courses are really, they're they're not easy, but they explain things in a way that's really attainable. And sometimes thinking through, graph databases, it feels like, especially from a data science perspective, it feels like it can be overwhelming. But I just want to say, they're written really well. They're very manageable. So it is 4 courses that we do recommend. I would say the time in investment is definitely worth what it's going to mean to you professionally. So I would definitely say dive in. Also, we have a community board. So if you have questions, come join the community. Ari always makes sure that we get back to everybody. So he will be there monitoring regularly. So if you're working on something, if something's a challenge, always reach out to us. If you didn't have questions, I wouldn't have a job. So don't be shy.
Well, thank you again. So everyone, thank you so much. This recording will be available not only in our community, which is community.neo4j.com, but we'll also make sure this is available on our YouTube channel as well. So thanks, everybody. And until next time.